Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is a series of 5 problems on friction, in particular the application on um, bodies that undergo impending motion, and that motion is by sliding or by slipping. Level 21, the strut AB of negligible mass is hinged to the horizontal surface at A and to the uniform 25 kilogram wheel at B. Determine the minimum couple M applied to the wheel, which will cause it to slip if the coefficient of static friction between the wheel and the surface is zero point 0.4. So remember, the condition here is that the wheel is on the verge of slipping, or it will cause to slip, and the coefficient of static friction between the wheel and the surface is zero point 0.4. So it is about to slip, or the wheel is on the verge of slipping. So we have to apply for the solution the weight 25 times 9.81. Then we have the force P. The effect would be compression on AB. We'll call that P. There are two components. It is in the vertical component of distance is 150. The hypotenuse is 250. So this is 150 divided by 50 is 3 parts. The hypotenuse is 250 divided by 50 is 5 parts. So the horizontal component of distance is 4 parts. So 3, 4, 5. 3 vertical, 4 horizontal, 5 vertical. Then we have the normal reaction at on the ground here on the floor. Call that NF. Then friction should be to the left. And this friction is maximum frictional resistance, zero point 0.4 of NF. So that if we sum up moments about the center of the wheel later, the moment M is equal to F max times R plus the vertical component of P, which is P times 3/5 or 0.6 P. The horizontal passes through the center, so it has no moment there. So it is P times zero point 0.6 times radius, which is 0.15 mm. So first, summation forces vertical equals 0. So NF plus P times 3 over 5, vertical component of P, equals 25 times 9.81. NF therefore is equal to 245.25 minus zero point 0.6 of P. Then summation forces horizontal, P times 4 over 5 equals F. And take note, F is maximum because the wheel is on the verge of slipping, and it is equal to zero point 0.4 times the normal force. So 0 0.8 P equals F, and F is zero point 0.4 times the normal force, which is 245.25 minus zero point 0.6 P. Solving for P, P is equal to 94.33 newtons. Having found P, we can now solve for F, or F max is zero point 0.8 of P. P times 4/5 or zero point 0.8 of P. So zero point 0.8 of 94.33 is 75.464 newtons. Finally, summation moment about the center equals 0. So moment equals friction max 75.464 times 0.15 plus the vertical component of P, which is P 94.33 times 3/5 or zero point 0.6, and the moment arm is the radius of the wheel, 0.15. Solving for M, M is equal to 19.81 Newton meter. So that's it for this problem. Level 22, a uniform crate with a mass of 30 kg must be moved up along the 15-degree incline without tipping. Knowing that the force P is horizontal, determine the largest allowable coefficient of friction between the crate and the incline, and letter B, the corresponding magnitude of force P. So here is the given figure, and remember the condition: the crate So we have to determine the largest coefficient of friction between the crate and the incline and the corresponding magnitude of the force P. So the condition is the crate must be moved up along the 15-degree incline without tipping, and of course without sliding or without slipping. So for the solution, let's apply the weight of the crate, which is 30 kilograms times 9.81. Then we have the normal reaction at C because the condition is without tipping at C. The normal reaction must be at C, and there's no normal reaction at D. So we have N sub C, then we have friction, which is mu sub S times N sub C going to the left opposite to the impending motion, which is up the 30-degree incline. And next is we have the distance from C to the center of the crate, which is half of distance diagonal AC. The length of diagonal AC is L square root of L square plus L square, or L square root of 2. Therefore, this distance is L over 2 square root of 2. This distance from the center to C, that's L over 2 square root of 2. Since the angle supposedly between this distance and this incline CD is 45 degrees, this is also 45 degrees, and since this is already 15 degrees, if we draw a right triangle with base horizontal, then the measure of this angle is 45 degrees minus 15 degrees, so 30 degrees as shown. Then we have to consider, we have to superimpose the normal and the tangential axis so that we can have we can solve for N sub C. So this is also 15 degrees and this is also 15 degrees. So summation forces normal equals 0. N sub C equals 30 times 9.81 cosine of 15 degrees minus plus P sine of 15 degrees, the normal component of B. So simplifying, N sub C is equal to 284.27 plus P sine of 15 degrees. Then summation forces horizontal or summation forces tangential equals 0. So we have P cosine 15 degrees equals 30 times 9.81 sine of 15 degrees plus mu sub S N sub C. So substituting N sub C from this equation here, so P cosine of 15 degrees equals 76.170 plus mu sub S times quantity 284.27 plus P sine of 15 degrees. Combining like terms, so P cosine of 15 degrees times L, so we sum up moment about point C equals 0. So horizontal component of P is P, or the tangential component of P is P cosine 15 degrees, and the distance is moment arm is L. Then minus P sine of 15 degrees, the moment arm is also is L. Then minus or equals 30 times 9.81 times this distance. This distance is L over 2 square root of 2 cosine of 30. So equals 30 times 9.81 times quantity L over 2 square root of 2 times cosine of 30. This distance here, horizontal distance, the moment arm of this weight. So cancel out L and solve for P. So solving for P, P is 254.9 newtons. Having found P, that's the answer to part B. Then we can compute the largest coefficient of friction between the crate and the incline, and that happens when we have impending tipping and impending sliding also. So because of this condition that we have to compute the largest allowable coefficient of friction. And to do that, we substitute the value of P into this equation, leaving mu sub S as the only unknown. So P to 54.9 cosine of 15 degrees times, we canceled out L, by the way, so, or from this equation, so 30 times 9.81 times sine 15 degrees is 76.17 from this equation here, plus mu sub S, quantity 287.27 plus P 254.9 sine of 15 degrees. So leaving mu sub S as the only unknown, solving for mu sub S, so mu sub S is equal to 0.4855. So that's it for this problem. That's the answer to part A. Level 23, the 100-pound wheel rolls on its hub up the circular incline under the action of the 25-pound weight attached to a cord around the rim. Determine the angle theta at which the wheel comes to rest, assuming that friction is sufficient to prevent slippage. What is the minimum coefficient of friction which will permit this position to be reached with no slipping? So here is the given figure, and for the solution, we have to apply the weight, which is 100 pounds. Then next we have the tension here, which is 25 pounds. Then the normal reaction, let's call it NH. Then friction, which is up to the right, opposite to the impending sliding of this wheel. Then it is mu sub S times NH, where mu sub S is to be determined also later. Then for the distance, so call this theta. The measure of the angle here with the normal is also theta. Then for the normal reaction, summation forces normal equals 0. So N sub H equals normal component of 125 combined is 100 plus 25 cosine of theta. So NH is equal to 125 cosine of theta. Then for the distance between the 100 pounds and this point here, because the radius is 3 inches and the angle here is angle with the vertical is theta, so that distance is 3 sine of theta. That distance there is 3 sine of theta. Then for the moment arm of the 25 pounds, because we plan to sum up moments about point H here, so this moment arm is, of course, radius of the big wheel 8 inches minus 3 sine of theta. So summation moment about H equals 0, 100 times 3 sine theta, then equals 25 times quantity. This distance is 8 inches minus 3 sine theta. So 8 minus 3 sine theta, the moment arm of the 25-pound force from point H. So this distance here is radius of the big wheel 8 inches minus 3 sine theta. This is 3 sine theta. So simplifying, 375 sine theta equals 200. So from here, theta is arc sine of 200 over 375. So theta is equal to 32.23 degrees. Then for mu sub S, minimum mu sub S, summation forces tangential equals 0. So mu sub S times NH equals 100 plus 25 sine of theta. Since theta has been found and NH is in terms of theta here, 125 cosine theta, then we can solve mu sub S. So minimum coefficient of friction. So mu sub S times NH, which is 125 cosine theta, equals 125 sine theta. Cancel out 125. So mu sub S is simply tangent of theta, and theta is 32.23 degrees. So mu sub S can now be computed. It is equal to 0.6305. Level 24, a worker slowly moves a 50-kilogram crate to the left along a loading dock by applying a force P at corner B as shown. Knowing that the crate starts to tip about edge E of the loading dock when A is 200 mm or 0.2 meter, determine letter A the coefficient of kinetic friction between the crate and the loading dock, and letter B the corresponding magnitude of B of the force. So this is the given figure. Then for the solution, so let's have the weight first of 50 times 9.81 newtons. Then since the crate is about to tip about E or starts to tip about edge E, then we have the normal reaction at E, N sub E friction would be to the right, and it is equal to mu sub S times uh, kinetic friction. So it's about to tip and it's about to tip at E, and after that it will slide or it will continue to move. So therefore, the frictional resistance at E is coefficient of kinetic friction mu sub K times N sub E as shown to the right. Then the angles are already found. Then this distance, half of 1.2 is 0.6. Since the A is 0.2 meter, then the moment arm of the weight about E is zero point 0.4 as shown, 0.4 meter. So first, let's have summation moment about E equals 0. So horizontal component of P cosine 15 degrees. So we have counterclockwise positive. The moment arm is 0.9. Then the vertical component will also be counterclockwise about E. So plus P sine of 15 degrees times this distance is 1 meter, 1.2 meter minus A, which is 0.2. So plus P sine of 15 degrees times 1, then equals the moment of the weight 50 times 9.81 times 0.4. So from here, we can solve for P. P is equal to 173.9 newtons. So having found P, we sum up forces horizontal to solve for mu sub K. So, but before that, let's solve for NE. NE plus P sine of 15 degrees equals 50 times 9.81, where P is 173.9. Again, summation forces normal equals 0. NE plus vertical component of P, which is 173.9 sine of 15 degrees, then equals the weight 50 times 9.81. And sub E, therefore, is equal to 445.49 newtons. So having found N sub E, we now sum up forces horizontal. So mu sub K times NE 445.49 equals horizontal component of B, P cosine of 15 or 173.9 cosine of 15 degrees. Solving for mu sub K is equal to 0.3771. Level 25, the cylinder shown has a weight of W and radius R. Expressed in terms of W and R, the magnitude of the largest couple M that can be applied to the cylinder if it is not to rotate, assuming the coefficient of static friction to be letter A, part A 0 at A and 0.3 at B, then at part B 0.25 at A and 0.3 at B. So here is the given figure. Let's just generalize the solution. So for the solution, let's have the weight first applied at the center. Then the normal reaction at B, call that N sub B. Friction at B, which is to the left, opposite to M, and that is mu sub SB times NB. Then we have normal reaction at A to the right. Then friction, which is opposite to moment, so it is upward, mu sub SA times NA. So first, summation forces, normal or vertical equals 0. So N sub B plus mu sub SA NA equals W. So since mu sub SA is 0 in part A, so NB plus 0 equals W. So that means NB equals W. Then summation forces horizontal equals 0. NA equals mu sub SB times NB. Since mu sub SB is 0.3, NA is equal to 0.3 of NB. Then see, note that NB is W. So therefore, NA is zero point 0.3 of W. Lastly, summation moment about the center of the wheel equals 0. Then moment is equal to mu sub SANA times R plus mu sub SBNB times R also. So M equals mu sub SA NA times R plus mu sub SB NB times R. Take note that mu sub SA is 0. So M equals 0 plus mu sub SB 0.3 times NB, which is W times R. So moment is equal to 0.3 WR, 0.30000 WR to 4 significant figures. Then for part B, mu sub SA is 0.25, mu sub SB is 0.3, still 0.3. So NB is now same equation as this. Then we substitute the value of mu sub SA, which is 0.25. So NB equals W minus 0.25 of NA. Then summation forces horizontal, NA is equal to mu sub SB times NB. Then take note mu sub SB is 0.3. So NA equals 0.3 of NB. Substitute the value of NB, which is this. So we can express now NA in terms of W. So NA is equal to 0.3 of NB, and NB is W minus 0.25 of NA. Solving for NA in terms of W, NA is equal to 12 over 43 of W. Then substitute into this equation here to solve for NB in terms of W, or here. So 12 over 43W equals 0.3 of NB. So NB is 12 over 43W over 0.3. So that means N sub B is equal to 40 over 43W. Finally, substitute into this equation here to solve for M moment. So moment equals mu sub SA NA times R plus mu sub SB NB times R. So M is equal to 0.25 times quantity 12 over 43W times R plus 0.3 times 40 over 43W times R. So combining, solving for M, M is equal to 15 over 43WR, and that is approximately 0.3488 WR to 4 significant figures.